Alright, welcome back to my channel, or hello if it's your first time here. Thanks for stopping in. What we've got going on today is just going to be something simple. I realize I haven't made a video on Stormworks in a really long time, and that's because I was trying to finish my degree, and now that I'm all finished and I wrapped it up, I figured it might be a good time to start making Stormworks videos again. And in the meantime, while I wasn't making Stormworks videos, I kept an eye on like patches and updates, changelogs. So I have an idea of like some of the stuff that's been added to the game since then, and I have some ideas on some cool things we might do in the future to really push the boundaries of this game. Otherwise, for now, we're just going to do something really simple that accomplishes literally none of that. And we're just going to make a simple compact sliding door, and it's just going to use push buttons, a microcontroller, and a power source, and that's all we need. So just to cover what's going to happen is we're going to demonstrate the door functioning two ways, and we're going to give like the first part is going to be like a little tutorial on how to connect it up. So if you don't want to stick around and see how the microcontroller works and go into like the logic and code and see how all the logic blocks are connected on the microcontroller, then this first part of the video is for you, just a tutorial of how to set it up and get started. Otherwise, stick around and you'll get to see how all the logic in it works. So just to demonstrate, when we click the button, the door opens, and then the button turns off. So when we send a button press, for example, if we press now, the microcontroller is maintaining a state that this button was pressed. So there's an on state in the microcontroller right now for this button, and the other one hasn't been pressed, so it still has an off state. So there's two states there that are going on, one for each button, and then with some logic it manages between them to open and close the door regardless of which button you press or whether one's on or off. So that's basically how that works, and additionally this also works if you just want to have a one-way door. We can just delete a button and not have one of the sides of the microcontroller hooked up, and it will just work as a one-way door. So to demonstrate that, we'll just delete the button. Sorry, I added the button back. I want to delete it. Okay, so now we'll simulate a one-way door. So there's nothing there connected. We can't get in, but if we come over here, we can open it up, pretend we just walked through it, close it, and then now we're right back where we were, where we can't get into this door. So it works two-way, one-way. It's up to you. It's the same controller, just two ways of hooking it up. So I'll put this button back and then just give you an idea of how to hook it up. So if we go into our logic tab, we'll start with power and just make sure that our buttons have power and that the door has power. And I'm just using a battery for this, but you could use like a generator or an alternator, whatever power you have to power this thing. As long as you have an electrical source, you can just hook it up. It'll be fine. And then if I clip into this door just a bit, I'll try to get it to where we can see both buttons, but maybe not. There we go. You see we have a button on the right side and the left side. That's our microcontroller there. We have two nodes, one labeled A, one labeled B. So we'll just consider this right side of the door side A. We connect on the button, we have an input and an output. So we want the press signal where it says pressed. We'll send pressed to the A input on the controller, and then we'll do the same thing for button B to side B. And this is also arbitrary. If you really wanted to, you could just crisscross these and it's still going to work. I just labeled it because I'm picky and I like my stuff to be nice and neat, especially when your stuff gets complex in this game. So that's how you wire the buttons to the controller. And then the last thing is to take the door signal and wire it to the door, to the on-off signal on the door, and you're done. Now, in the case where you just wanted a one-way door, if we just remove this button again, you can see that this input is just dangling. Just leave it disconnected and it'll still work. Alternatively, like this could just be disconnected. Sorry. So this side could be just a block, and this side could be just a button. And then if we hook it back up, this works the same way too. So it doesn't matter which side of the door. If you just want one button on one side, just only connect one side to that side, and it doesn't matter. And it actually doesn't matter if I go like that either. You just need to make sure your buttons are uniquely connected to one of the inputs on the controller, and it's going to work. So just as an example again, since we've done this with the other side now, it still works. And so that's how you'd use this controller. So the things that we use to make this, for the door, you want to use the sliding door that's labeled electric, and it says it has electrical connection. This other door, just the logic inputs on it are just for a lock, so that doesn't work. You will want to use the electric door, so you have all the logical connections you need to hook this controller up and make it function like this. And then we use the push buttons as opposed to the toggle buttons. If you use the toggle buttons, I don't know, it might work. You can try it, but I designed it to work with push buttons, so I recommend use the push buttons and nothing else. And then lastly is like the microcontroller, a power source, blocks to frame it in. That's all you need to build this. That being said, I'll link the Steam Workshop page to my Steam Workshop for this controller in the description. You can go there, subscribe, use it in your own project. If you want to, you can change it, modify it, share it with other people, do whatever you want with it. Credit me, don't credit me. Doesn't matter to me. Use it how you want. I make these videos for fun, and I'm not picky about who owns intellectual property or not. That being said, just do what you want with it and have fun with it. That's really all I make these videos for, and that's all I care about. So that concludes the whole tutorial part of the video. So if that's what you came here for, you can feel free to click off and go use this in your own creations and have fun with it. If not, if you want to stick around and see how this works, I'm going to get into the microcontroller editor now, and we're going to go through how this works. So starting with the design, like the little schematic page, we have two inputs that are for on-off inputs, and then we have one on-off output. And I've labeled them A, B, and door. Then going into our logic page, we have we're going to go left to right, so over here on the left we have A and B for our buttons, and then we have these push to toggle blocks. And so what these do is they basically create an internal memory that maintains the last button state. So they start zeroed out, and then for example if I push button B comes on and updates the state contained here in the memory to on, and then the button turns off. and then the same thing happens on button A. And I've chosen to do it this way for there's two reasons. The first reason being that you could use toggle buttons, but when your door is closed and your buttons are on, which is something that can happen, that looks weird. It doesn't make sense to have your buttons on and the door is closed. Or in other words, lit up and the door is closed. So that's the first consideration with that. That looks kind of weird. The second thing is, I just don't want to add the extra lines of code to the Lua script to maintain button state. It's only like 1 or 2 extra lines of code, but just to keep it super simple, nice and neat, I've just done it this way. You could do it in the Lua script, I think. I believe you could just create a like a variable up here. As long as you don't initialize it in the onTick function, I think it will work. But I'm not positive. I haven't tried it. But yeah, Lua is not my most familiar programming language, so. But I think it's something you can do. So, but next we have this composite write block, and so you can specify like how many channels you want here, all the way from 1 to like you can have 32 on-off channels if you have a need for that. We just need 2 channels, and we'll start with channel 1, and that's because we're creating a new composite signal. If let's say for example you already had a composite signal, you could specify like the exact number. So like if I had for example like 7, if I had channels 1 through 7 used up on a composite signal already, then I would start at channel 8 and then start at channel 8, and then I could just specify like, yeah, I just want to add 2 more inputs starting from channel 8, and so then I would have 8 and 9 would be for these buttons. So, or I think you can do variable from node, and I'm not sure exactly how that works. I've never come across that yet, but that's another option where you use this to update which channel it starts from. But we'll just start with the default 1 and add 2 channels to that. Like I said, we're creating a signal, so we don't have to send an input in here. We're not adding on to a existing composite data signal. We're just creating one, so we'll just leave this purple node unhooked. And then we'll just put these back to keep it clean. And then these feed in these so these push to the button states, the on-off states from here. They just feed through this into our Lua script, and then we do some just a little bit of use like a little bit of logic, and then we write the updated door state to channel 3 in the script. So then we have a read block here where we read on channel 3 from what is output from the script, and we send that signal to the door, which handles if the door is open or closed. So if we go into our script, we'll walk through it really quick. It's like 8 lines of code. So we need to start with the concept of what happens. Like I said earlier, we have the ability to have our door to be a 2-way door or a 1-way door. So what happens if one of our inputs is dangling? We have no input on, like, let's say button A, for example. If we consider button A the outside of the door, then we have a door set up where we can leave, but we can't come back in. So in that case, what happens here is when we read on channel 1, we read that Boolean value on channel 1, we get nil as a result. Right? Actually, like, this may be smart enough that it sets it to false, but we can't be sure. So like, let's say the worst case is like, yeah, it just happens to be nil. and we don't handle that, then we have a problem because we're trying to compare nil to some other value, and nil technically is valueless. It's like undefined in math. If you think of it in like math terms, it's basically we have something undefined. We don't know what its value is. So how can we compare something if it's valueless? So in order to counter, or in order to to correct for that and can take that under consideration, I've created this function called tabool. And what we're doing is we're ensuring that we have a Boolean value. And so this function takes an input argument of v. So this variable v, we're going to do like just return a Boolean expression. So the evaluation of that Boolean expression. So what we're looking at is like, so if v is equivalent to nil, and v is equivalent to false, then we're going to return false. Or if just one of these, like, so basically what we're saying is only if the Boolean was true, we return true. If it's false, we return false. If it's nil, we return false. So we're assessing the truthiness of the variable we pass in. So let's say if in this v equivalent to nil, so if it's not nil, then we move to this part of the expression, and if it's not false, then we know it had to be true, or it had to have a value. So then we were even handling the case where like the input is like a floating point or a number or integer. So we're handling all the cases basically. As long as there's some data there and it's not nil, or that data is not nil and it's not false, it's going to return true. Otherwise, we just make it false. So that's how we're handling all those edge cases right there, just in one line of code. So now that we have that figured out, we just go ahead and do our read on channels 1 and 2, store them as, button A, B, and then we have to face the problem of we have 2 buttons, but we have 1 door signal that needs to go out. Well, this is where logical operators come in, and this is like basic programming knowledge here. So Lua doesn't have like an XOR logical operator built in, so we need to create a function that performs logical XOR. So the easiest way to think of this is let's set up a truth table here. So we have our values A and B are our input variables, and then we have P, which is our truth value. So let's say if A is well, and then so we'll treat 0 as false and 1 as true. So if we have both of our inputs are false, then our output truth value is going to be false. And then let's say if only B is true, then our output truth value is 1. And then the opposite of that, where A has a value of true, but B is false, then our output truth value is also true. And then the last case, where both are true, then our truth value is false. So this truth table defines like when we put in 2 Boolean values, what the output should be. And so really what we're saying here is as long as A is not equal to B, or the opposite, if B is not equal to A, then we return a value of true, meaning the door should be on. If only one button is on, the door should open. Otherwise, if both buttons are on, it should be closed. If both buttons are off, it should be closed. That's what we're doing here. So we can do this, just another little simple function that we've made here. We'll call it XOR, and we'll accept two input variables, A and B, and then we'll call our to Boolean function on both A and B, and then we'll return A not equal to B. And so if A and B are not equal to each other, so they're not both false, they're not both true, then we'll return true, and otherwise we're returning false. So this should match exactly the truth table. So moving on, now that we've got this whole thing figured out of how to work with that, all we have left is to write the output. And so we'll call setBool on our output, and we'll write to channel 3, and then the data we're going to write to channel 3 is just the XOR, the logical XOR of A and B, which are the two booleans that we read in. And that's going to finish our script. So we should have something that functions and does what we expect, and as you've seen already in the video, it does. And we tested all the cases, so regardless of which side of the controller is hooked up, we checked both of those. We checked if both are hooked up or just one, and everything seems to function like it should. So I think just by doing this simple check here, we've handled all the edge cases, and we have something that's going to continue to function like we expect. And so that wraps up the whole video. Hopefully this was informative. Hopefully gave you a little bit of ideas of how to make your own controllers, or how to at least get familiar with how to hook things up to like the Lewis script block in the game and get started writing code. And other than that, hopefully it was just interesting, and hopefully this gives you a place to start with either modifying this and changing it and making it something of your own. Maybe you want to add lights that turn on when the door opens, or some other thing. I mean, there's a ton of things you can do with this game, and so hopefully that inspired you to make something like that. Otherwise, thanks for taking the time to watch the video. If you enjoyed it, please subscribe to the video. The channel. Subscribe to the my Steam Workshop. I have a couple other things on there. Feel free to pick and choose what you want. Do what you want with this content. Yeah, it's all up to you. It's all up to you. Other than that, thanks and have a nice one.